Welcome to qnawire.
Okay, so in this case, we're asked to approximate the integral of a function over a region R. R is a rectangle, but we're going to subdivide this rectangle. I'm going to make a picture of it, but let me just write the information we have in here. So we want x to vary between 1 and 1.6, and we will want delta x to be 0.2. So we're going to have three subintervals, right? 1 to 1.2, to 1.4 to 1.6. Our y will be changing between 2 and 3.2, and the changes in y, we want them to be 0.4. So again, also just three subintervals, like 2 to 2.4, 2.8, and 3.2. And so the picture will be something of the form. I should have a longer y-axis, just so that I try to make the picture with a proper scale, right? Let's say, so this is, let's say 1, 2, 3. Let's put a 3.2 in here. All right, so this will be our y range. And then here it's going to be from 1 to 1.6, 1, 2. So just stop here, 1.6. This is going to be our x range. Of course, the rectangle. Let's just prolong here the picture. Oh, not here. Let's go upwards. Okay, it's not a great picture, but right. So this is going to be our rectangle in here. Right, and we're going to make subdivisions. So we're going to subdivide this into 3, and same here into 3. Right. So let me just write what the subintervals in x will be. So subintervals in x, and I'm just going to list them because we need the midpoint for the calculation. It's said that we're using the midpoints in here to approximate. So I'm going to have the interval from 1 to 1.2, then interval from 1.2 to 1.4, interval 1.4 to 1.6. So the midpoint here, let me call it m, will be 1.1. Midpoint here will be 1.3, and the midpoint here will be 1.5. And the subintervals in y, let's just do the similar calculation. So this will be 2 to 2.4, then 2.4 to 2.8, and then 2.8 to 3.2. And our midpoints here will then be 2.2. Here we're going to have 2.6, and here will be 3, right? So our sum will have, of course, 9 terms. Will be this subinterval, because we're going to have 9 rectangles here, right? So we need to calculate the area, the integral of the function over each of these rectangles, evaluating at the midpoint. So our approximation for the integral of f of xy, dA, right, will be, okay, first term. Let's start with the first subinterval here of x. I'm going to call it blue, the blue term, and we're going to make the combinations with this one, and with this one, in which case I will have, so f at the midpoint of this one and this one, so f at 1.1, 2.2, times the area of this rectangle, but the areas will always be the same, right? The areas will always be, so area of each subrectangle, because we are subdividing always with the same delta x and delta y, the area of each subrectangle will be the delta in x times the delta in y, which is 0.08, right? Yes, 0.04, yeah, 0.08. So I'm going to have, so the first case times 0.08 plus, now we go to the next one, which we're still on this subinterval in x, and we move on to this subinterval in y, 2.x times 0.08 plus f of 1.1, and then here it was at 3 times 0.08. Okay, so these would be the first, if I paint them in the picture, the ones I just did are this rectangle, and this rectangle, right? And now we just repeat this for all of the others. So plus, now second choice, the second midpoint was 1.3. So I'm going to have 1.3 and 2.2, 0.08, plus f of 1.3, 2.6 times 0.08 plus f of 1.3 and 3, 0.08. And now we go to the last ones. So in this second row of summands, I've done now these three middle rectangles. And now the last one, the midpoint would be at 1.5. And we have 1.5, 2.2, 0.08 plus f of 1.5, 2.6 times 0.08 plus f at 1.5 and 3 times 0.08. All right, so this is going to be 0.08, so factor in all of them, times the sum of the values of the function at each point. We're given all of them, so you just have to sum really everything that's on the table, right? So it's going to be -2, -4, +10, -5, +3, +5, +2, -3, +5, right? I just copied down in some order all the values of the table, right? We're given all of these ones that we need. So let's see, -2 -4 is -6, -6 plus 10 is 4, 4 minus 5 is -1, plus 3 is 2, plus 5 is 7, 9, minus 3 is 6, plus 5 is 11. So I obtain 11 times 0.08, which is what, 0.88 perhaps, right? So 11 times 0.08, yeah, 0.88. Right, so this is a value that you need to put inside the box.